Alright, here is a problem that you could simplify using the laws of exponent. This one here, there's a couple things you can do. If you notice, I have 5/20ths. That's the first thing I kind of think of. And so I can reduce this by 5 and make it 1/4. Alright, this also has a power-to-power rule, so we kind of have to be careful here. So I'm going to go ahead and call this one back, just so you can kind of see this. So I'm going to go ahead and distribute. Now remember, everything has a power. The 5 has a power, the y has a power, the 20 has a power, and the x has a power. And I'm going to distribute this 4 to everything. I mean everything in every exponent. Alright? So I'm going to go ahead and rewrite everything just so you can kind of see what it looks like. So it's remember, I'm going to go ahead and reduce this and make it 1 and 4. So I'm going to rewrite it like it should be written. So it's going to be 1 to the first power. All right, and we're going to multiply 4 to it. If I can get my 4 to right. So the only way I can get it right. All right, and then the x, and then that has a power of 3 on it, and we're going to multiply 4 to that. And then the y has a power of 1, and we're going to multiply 4 to that. And that's just on the top. Now the bottom part, we have a 4, and it has an exponent of 1, so we're going to multiply 4 to that. Then we have x to the first power, and we're going to multiply 4 to that. And then we have y to the 5th power. We're going to multiply 4 to that. Alright, now you notice our exponent on the outside is gone because we distributed already. Alright, so I'm going to rewrite it so you can see it a little better. That's what we're going to do here. And so the top part, remember I talked about bunk beds, the top part, or the top bunk, we have a 1, and 1 times 4, that's this part right here. 1 times 4 is 4. And then x, 3 times 4 is 12. And then y is 1 times 4 is 4. Now I really don't need the 1 here, but I'm going to leave it here just so we can go. Alright, 4 to the 4th power, 1 times 4 is 4. Then x to the 4th power, because 1 times 4 is 4. And then y to the 20th power, because 5 times 4 is 20. I'm going to go ahead and delete this because we really don't need this now. Alright, so I'm going to rewrite this. 1 to the 4th power is 1, and I'm still going to keep it here just right now. X to the 12th, y to the 4th. And I'm just going to simplify my numbers. 4 to the 4th power, well, if 4 to the 4th power means I have 4 times 4, which is 16, and then I got 2 more, that makes 16, so this should be 256. Let me check here. 16 times 16, that's 36. That's 9, that's 6, that's 1. Yeah, 256. So it should be 256, x to the 4th and y to the 20th. Alright, so there's a couple things we can do here. We can subtract, and this is where some kids mess up. They get two things confused about. If we subtract, notice the divide here, this little divide sign right here means subtract your exponents of the same base. So my exponents, no matter what, are going to be, my number's going to be 1 over 256. Alright, now if you notice I got 12 x's on top and 12 x's on bottom. So really that's like saying x 12 minus 4. And then the y's, we have 4 on the bottom, and 4 on the top and 20 on the bottom, but we still can subtract them and say 4 minus 20. Notice when I subtract this way, all my numbers are on the top. So really this is x is 8, y negative 16, all over 256. Now remember, my exponents cannot be negative, so because he's unhappy, we're going to move him to the bottom bunk, or the denominator side. So actually my answer is going to be x is 8, and then have 256 y to the 16th power. Now, I do want to show you, now that's if we do the subtraction thing. We can do the old bunk bed method, and the one that I talk about in my classroom. So I'm going to erase this just so you can kind of see what I mean by the bunk bed method. The bunk bed method, I just kind of basically just treat it as a bunk bed, top bunk and bottom bunk. And I look at it as, and let me give you an example, like I have so many X's on the top and so many X's on the bottom, I match them. Whatever I've left, that stays on the top or bottom. Now whatever we leave it, it stays there. It's a positive exponent. So that means it's happy. So if you end up with something like this, and you match them, it's 2. The exponent's x squared. It's positive. It's not negative, because if it only becomes negative if you're subtracting them, and we're just matching them. And a lot of kids will say, "Oh, this is x minus 2," and next thing you know, they put it on the top bunk, and it's wrong. So we don't want to do that. So if you match them, just wherever they end up, that's where you leave them. So we're going to just kind of visualize this, and this is the best way to do this. Alright, so we're not going to change, and I'm going to leave this in a different color. We're going to say it's 256 and 1 on the top. Alright, so I'm looking at my x's. So this right here and this right here. I have 12 x's on top and 4 x's on the bottom. Think of a bunk bed. I have 12 on the top and 4 on the bottom. When I start matching them, how many do I have left and where are they? Well, if you start matching them, so there's the 12 X's on the top bunk, there's the 4 on the bottom. If you start matching them, 1, 2, 3, 4, you should have 1, 2, 3, 4, 5, 6, 7, 8 left on the top. Alright, and so now, if I look at the Y's principle is the same thing. I have 4 Y's on the top bunk, I have 20 on the bottom bunk. So think about it. I have Y, 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 and then I have 20 of them on the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. If I start matching these, then that whatever's left is on the bottom bunk. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So my answer should be y to the 16th on the bottom bunk. See, because they're positive, you don't change it. So this is our answer. And you don't have to have the 1. You can eliminate it and write it like that as well.